All right, everybody, we are in lesson 1-4, which is on distance. Now, there's several things you can do for distance. There's a distance formula. If you want to, kind of cheat between 2 points, if they're on a coordinate plane, you can do the Pythagorean theorem. And I'm going to show you guys how to do that, not necessarily in this lesson, but maybe later on. And also the number line. And this is just simply counting. All right, let's get into it. All right. So distance on the number line is literally for them in this lesson a subtraction of the numbers that the letters are on, but it has to be an absolute value because distance is always positive. I could get in my car right now and drive backwards to Walmart, and it would still be a positive distance. All right. So like I said, I could go to Walmart backwards and it's still a positive distance. Let's see what we got here. Example number 1, find the distance on the number line. Now, I don't particularly like the way they do this because it's kind of long, to be honest with you, but I'm going to show you their way, and then I'm going to show you a shortcut because I am a shortcut kind of person. All right, they want the distance from C to F. There is C on the number line at -1. There is F on the number line at 5. So C comes first. So I'm going to put C at -1, and I'm going to subtract F, which is on 5. And I want you to notice they've got these little bars for your absolute values. Okay, well, listen, -1 minus 5, you got to figure out what that is. And if you need a calculator, then do it. But basically 5, or is it being subtracted from a -1? So it's going to be a -6, but the absolute value of that is a +6. And here's the shortcut. Start off at C. You're asking yourself, how many times I have to move to get to F? 1, 2, 3, 4, 5, 6. And the answer is 6. That's your shortcut. So start off at the first letter. Count how many moves it takes to get to F. 1, 2, 3, 4, 5, 6. Boom, the answer is 6. You can even do it backwards because distance is always positive. Still going to be a 6. 1, 2, 3, 4, 5, 6 from F to C. So the answer is 6. Why do you think this is always an absolute value? Well, this is always positive no matter which way you move. All right, let's go for a check for understanding. They want to find AE. Now, first off, I want you guys to look at the lack of an icon above AE. There's no line, there's no bar, there is nothing there above the AE. That means they're looking for a numerical answer. They're looking for the distance from A to E or from E to A if that's how you want to count. But I'm going to start on my first letter, which is A. I'm going to count how many times I move to get to E. So here we go. There's my A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, I love ACT. They're going to try and mix you up by putting the same answer with a negative, but here's the actual answer, +12. Boom, there it is. All right, if you're not understanding that, you can go online and get an extra example from your teacher. That is, if they sent it to you. And here comes example number 2. All right, determine segment congruence. Now, remember, the word congruent means they have the same measure, the same length, the same distance. Again, I want you guys to notice they do this by the absolute value because they're using the technical definition. I'm a shortcut kind of person, so I'm going to show it their way, and then, of course, I'm going to do it my way. All right, they want to determine whether C, B, and D, F are congruent. So let's start at C, which is on -1. And B, which is on -3. Oh, okay. Well, so they work at the -1 there. So it looks like they want my -3 to be first. So they are putting it backwards for you guys. And so we're subtracting the C, which is -1. My way, you don't have to worry about which one's first, but that's okay. I'm going to go with what they're saying. So -3 minus a -1. Remember, a double negative is the same thing as a plus. So -3 plus 1 is a -2. And the absolute value is a +2. Now, if I were to count this C to B, 1, 2, or B to C, 1, 2. I like it my way. My way's better. All right. So the length of CB is 2. Now we got to find DF. All right. So I see they started out with F because F is the one on 5, and they're moving to D. D is on the 2. Put a 2 right there. Subtraction in the middle, absolute value. 5 minus 2 is 3. The absolute value of a 3 is 3. All right, but my way. I'm going to start at C. I'm sorry, my bad. I'm going to move from D to F. So I'm going to start at D and move to F. 1, 2, I move 3 times. So the answer is 3. Or if you go backwards like they did, F to D. Starting at F, I'm moving 1, 2, 3 times. So are these congruent? Absolutely not. They are not congruent to each other. So we have a little non-equal. So it's basically an equals, and you put a slash through it to show they're not. They're not the same length. They're not the same measure. All right, next up, we are doing a check. So determine the length of AC and DB and if they are congruent. So it's still loading, but just to make life easy, I'm going to start at A. I'm going to count to C. So there's my A. I'm counting how many times I move. 1, 2, 3, 4, 5, and 6. So the length from A to C is 6. And you can always go backwards. From B to D, counting from B over to D, I'm moving once, twice, 3 times, 4 times, 5 times. So these are not equal to each other because AC was a 6. BD was a 5, and I would put that information in if it was loading. So I might have to pause the video here for a second to get it to load. I'll be right back. All right, back to it, you guys. Sorry, it took a second to load, and I didn't want you guys to have to wait. So the segments are not congruent. All right, so we got an online activity. So if you need some extra practice or your teacher assigns the activity, I'll let you guys take care of that. Let's see what we got here. Looks like I got to turn to the next page. All right. So in your workbooks, we are now at the top of page 29. All right. So everybody look at page 29. Here is the distance formula. Now, unfortunately, ACT is not going to give you this formula. You're going to have it memorized for the ACT. And if you're sitting in a Tennessee classroom like I am, because this is the Tennessee Revealed Geometry, Volume 1. Yeah, that formula sheet they give you guys, not going to have the distance formula on there. And if you're anything like me, I don't even like that formula sheet. Doesn't really give you anything you need. All right, but here's your formula for the distance, finding P to Q. You have 2 ordered pairs. P is our X1, Y1. They're both 1s because it's your first ordered pair. Q is X2, Y2, and they're both 2s because those are your second ordered pairs. And the formula is from P to Q, and again, there's no bar over it, which you guys notice there's no bar, there's no line, there's nothing above it, which means our answer is going to be a number. All right, square root, and in parentheses, X2 minus X1 squared, plus, and in parentheses, Y2 minus Y1 squared. All right, example number 3. Looks like we are about to have to plug in some information. We need to find the distance from J, which is 4, 3, to K, which is -3, -7. And they want J to be X1, Y1 because they give that to you as your first ordered pair. And they want K, -3, -7 to be your second ordered pair, basically because that's the second one they give you. And they give you the formula right there. All right, so we're going to fill this in together, you guys. X2 in your problem is your second X. So you're going to look at being -3. And we're going to subtract X1. And in X1, I'm not really sure why they're not plugging that in, but the X1 should have been 4. So I guess I'll plug it in right there. All right, Y2, that's your second one. Your problem is -7. And we're going to subtract the first Y in your problem, and that's going to be the 3. So I'll go ahead and put that in as well. All right, we are ready for calculator time. Or if you're good with your math, -3 minus 4 is a -7. And we're going to leave the parentheses in square because we're showing every single step at this point. Your plus sign comes down. -7 minus 3 is a -10. We're going to leave our parentheses in square because we're showing every single step. All right, -7 squared is a 49. Now listen, if you've got the type of calculator that if you do not put this in parentheses and you just put -7 squared, your calculator is probably going to give you the wrong answer. So make sure that -7 is in parentheses so it gives you a correct answer of 49. -10 also needs to be put in parentheses before you square it, because some calculators, if you don't, will give you a -100, and that's not correct. A negative times a negative is a positive. So it'll be a positive 100. And when you add those together, you get a positive 149. So it looks like the square root 149. You might want to grab your calculator, put that in. If your teacher has shown you how to break down a radical, you'll need to do the factor tree possibly, or whatever your teacher shows you to break down a radical. They want the approximate distance. I'm assuming they want it as a decimal, although up here it does not say what to do, but the radical does not break down. So if you want to change that to a decimal, and again, it doesn't say what to round it to, so I'm going to round it to the 10th, which is one number after the decimal. I got 12.2. Again, they're not specifying which one. Yeah, it doesn't specify in your book, so there we go. We'll just go with it. All right, go online if you need an extra example. And we're ready for the check at the bottom of page 29. It says find the distance between A and B. Okay. We are going to have to do the distance formula. And unfortunately, I can't write on this page. And I haven't figured out how to hook up my tablet to my new computer yet, because I have to have an admin password apparently. So yeah, we're going to have to figure this one out. So we're going to have a big old square root. You're going to take 9 and subtract -4 in your calculator in parentheses. And if you're hearing me type, I put it in my calculator. Get my calculator to act right. All right, square root, open parentheses, 9 minus -4 squared plus, and then 5 minus -6 in parentheses squared. All right, and I got the square root of 290, which again does not break down. So I'm going to go to the icon that has a root with no little box right there. That one right there is for a cube root or fourth root or fifth root. This one's for a square root. And I'll put in 290. All right, moving on. Okay, looks like I'm changing pages. So I'm going to go to page 30 for example number 4. And they're wanting us to calculate the distance. All right. Okay, so let's see, I'll move on down here to step number 2, because they've got all step number 1 done. And it looks like I'm going to get ready for it to load. All right, I would love decimals. Don't you love decimals? All right, so they have made the 212.0, 151.6 my first order pair. So those are my X1, Y1. They've made the 435.3 and the 311.3 the second order pair. So those are my X2, Y2. All right, so I'm going to fill in here. All right, X2 is 435.3. And I'm subtracting X1, which is the 212.0. And plus, here we come my Y's. I think they're doing this backwards, I guess, to prove to you that it really doesn't matter the order you put them in. And it really doesn't. Let's see. So Y2 is your 311.3. And I'm going to subtract Y1, which is the 151.6. All right. Grab yourself a calculator. And we're going to put in 435.3 minus 212. 435.3 minus 212. And I get 223.3. So put that in. 223.3. And it looks like they did the math over here for me. 311.3 minus 151.6 is 159.7. And I want you guys to notice they're not squaring yet. And when you do, again, good habit is to put these in parentheses, because if your number comes out negative and you do not put it in parentheses before you square it in your calculator, it might possibly, depending on what calculator you got, give you the wrong answer. So I'm going to put in 159.7 in parentheses before I square it. And, oh, wow, 25,504.09. All right, I'm going to add those together. So I'm going to add 49,862.89 to my 25,504.09. All right, looks like I got 76,366.98. All right, and they want me to take the square root of that. In fact, they want me to take the positive square root of that. All right, it doesn't tell me, does it, to round it to? I'm looking up here to see what it says to round it to, because in geometry, you always want to make sure you look back and you're given the answer they asked for. So what's the distance? Take the positive square root. So it looks like I'm going to approximate it. That's what the little squiggly right there means, to the nearest tenth. 274.5, because the number after the 5 is a 3, which means the 5 does not move. So they are approximately 274.5 feet apart. All right, you guys. Does it seem reasonable? Absolutely, it seems reasonable, and I'll let you answer why or why not. Okay, got a check. This is our last check before we go to the practice. All right, we got snowboarding. Let's see, Manuel wants to go snowboarding with his friend. The closest ski and snowboard resort is approximately 20 miles west, 50 miles north of the house. Manuel picks up his friend who lives 15 miles south. Oh, I love how they do this. There's my positives and negatives, with east and south. I'm sorry, west and south. All right, so how far away are the two boys with the resort? Okay, well, it looks I'm going to need some paper right here because I haven't hooked up my tablet yet. They haven't given me the password for my new computer, so let me get some paper here. All right, the very first one says approximately 20 west. Now, west is to the left, so that 20 is going to be negative. 50 miles north. North is up, so that's 50 is going to be positive. All right, got a friend. He lives 15 south and 10 miles east. I want you guys to notice this is our trick question. They put those backwards for you to try and mess with you. Remember, on a coordinate plane, you move left or right first. And since east is to the right, it's going to be a positive 10. That's going to be your first number. South, you remember you always move up or down on a coordinate plane second. South is going to be down, which is negative. And so that 15 is going to be negative. So watch out for that. You should have x1 negative 20, y1 50, x2 10, and y2 a negative 15. So watch out for those tricks, okay? ACT loves doing that stuff to you, so you really have to pay attention. You need a good night's rest before that test and something in your stomach, because you can get very easily distracted. Even if you're not a breakfast eater, you can get very easily distracted by a growling stomach. I chew gum during a major test to help for that. All right, so I'm going to put my big old root. I'm going to do y2, which is negative 15, minus y1, which is 50, plus sign after my close parenthesis and square, and then 10, which is my x2, minus negative 20, which is my x1, close parenthesis and squared. Gosh, you guys, I hope I get my tablet hooked up really quickly. It's just beginning of school and finding an administrator that is not doing something else to put in my password. All right, so negative 15 in my calculator, minus 50, is a negative 65, close parentheses squared, and 10 minus a negative 20 is 30, close parentheses squared. Well, negative 65 squared is 4,225, and 30 squared is 900. I'm going to add those two numbers together, 4,225 plus 900, and I get the square root of 5,125. And of course, so I don't know if they're going to want that as a square root. Let's see if it breaks down. It does not. I've got a decimal, so I'm going to round this to the nearest tenth. All right, so on my calculator, I got 71. Oh, what happened? Go back here, 71 point. And after the decimal, I got a 5/8. Well, that 8 makes that 5 round to a 6. All right, and go online for an extra example. Well, all right, you guys, that finishes up the notes for this lesson 1-4, which is on distance. If you have any questions for your teacher, make sure you ask them, okay? We love questions. It means you are wanting to learn, and this is on the ACT. So it's important that you remember all this formula stuff and the tricks that go along with them. All right, see you guys later.